Okay, let's discuss human communication in general, specifically aviation communication. We want to always remember that when you're listening to a radio, you're listening to 1950s technology with static, and it's basically two people can talk at the same time, and sometimes you can only hear part of the transmission. So there's a lot of challenges with there's challenges with just normal communication between two human beings because we have misunderstandings and whatnot. But there's also challenges, especially some challenges in aviation because of the noise factor. Noise and distractions make it more difficult. So we need to speak and communicate very clearly and specifically. That's why we have those phonetic alphabet, so that when we say letters or numbers, they come across very distinct and clear. We also have English is the international language of aviation, so we also have that issue. Foreign-born or English as a second language folks are going to have accents that may be difficult to understand, so they need to hear, and it's hard for them to understand our accent as native-born Americans, if that's what we are. So, clarity, using standard phraseology, all very important. When you're listening to manned aircraft, you're near an uncontrolled airport, you're listening to manned aircraft, you want to know what's going on, you're certainly hoping that they use standard phraseology. They state who they're speaking to and who they are, where they are, and what they plan on doing. And then repeat who they're talking to. And that way it makes it clear. We know the first things out of the mouth is they say the airport they're coming into, I suppose. And then who they are, Cessna 247. And then where they are, I'm 5 miles east of the airport. And what they want to do, landing. And then repeating again the name of the facility they're talking to. If it's an uncontrolled airport, they're talking to the traffic. Traffic in the Peachtree City airport, that's who they're talking to. If they're talking to a control tower, a controlled airspace, they say the name of the tower. Atlanta International Airport, control tower. They wouldn't say all that, but you get the idea. Okay, so we have a picture on the left here is a sectional chart of this it's down here in the corner, by the way, so don't mistake to be the first one. Let's see here. Let's get a red pen. What kind of airspace is that? That's the airport that you're seeing on the right side. That's a Midway Airport. Notice it's surrounded by a magenta solid, surface up to T. T means the bottom of this B airspace, which is the blue lines. Magenta lines, C. C airspace. But anyway, that's the airport. If you look over at this side, this is the chart supplement US diagram of the airport. You can see it's very complex. So manned aircraft coming in and out of this airport really need to communicate carefully, because somebody might be landing on this runway and then somebody landing on this runway, and if they don't have real clear communication, we can have aircraft bumping into each other. Okay, here's another example of an uncontrolled airport, right? It's magenta, we see that. Griffin Spalding Airport. This is so manned aircraft coming in and out of there, it's magenta shaded, so it's 700 above is E, 699 feet and below to the surface is G, so we can fly in all these areas. We can inspect this tower over here, for example, right? We just need to be aware how these airport traffic patterns, where the aircraft that are in that area, where they are and what they intend to do. If they're coming into land at this runway going this way, then we know that they're going to be over here somewhere coming in there. We need to be careful. We know where to look when they say they're on final approach for runway 32, for example. Remember that normal traffic patterns are left-hand patterns, so if there's somebody in the pattern, they'd be flying right over the top of that tower. We'd want to be aware of that. And we hope that they speak in standard phraseology so we can understand them. This is the vast majority of our communication issues are going to be with uncontrolled airports. All right, so somebody's going to say Griffin Airport, Cessna, I don't know, I'm just making this up. 1, 2, 3, 5 or 10 miles, say 10 miles southeast, landing runway 32, Griffin. Okay, so that's basically what they say. Pardon my writing. So we would know where they are. If they're 10 miles southeast, they're down over here somewhere. And since they said they're going to land on runway 32, they're heading that way. So they're heading that way, we can be aware of that. Because we would like to fly in this area, but we don't want to interfere with air traffic. So we need to be aware of that, aware of where they are. The big monkey wrench in all this is the fact that helicopters, of course, this is a manned aircraft. A Cessna 123 is a manned aircraft. They're going to be above you until they make that final approach into the land of the runway. Helicopters are going to be flying in our airspace. So, and helicopters, just in my experience, are not very careful about communicating, but still they're supposed to anyway. And that's a mitigating, something that we have to mitigate, be aware of the fact that they're going to be flying in our airspace. We also have issues with radios. This, again, is 1950s technology, radios with all the static and all of those issues, that it's line of sight. So if helicopters are flying at 300 feet or 200 feet above the ground and they're 10 miles away, there may be obstructions, hills, even trees, I suppose, buildings could interfere with their speaking on the radio, and they're just not used to it yet. They're still struggling with the whole concept of having to share airspace with drones. But we need to work together. Common traffic advisory. Oh, how do you know? This is the big question here, is how do you know what frequency to listen to? It's Magenta Airport, so we look over here and we see this little block here. Griffin, Spalding County Airport. AWOS is the weather, 1975. 958 is the airport elevation. The length of its left-hand pattern, traffic pattern, is the length of the longest runway, 3,700 feet. Okay, this little C, the little C, magenta, I don't have a magenta. The magenta colored C there is the sign for CTAF, Common Traffic Advisory Frequency. So that's the number, 123.75. Okay, here's Pocatello Airport. You notice it's in magenta, so it's controlled airport, correct? Yep, controlled airport. It has a kind of airspace that surrounds it as well, excuse me. And we have to know what that airspace is, right? Blue dashed line, that's going to be Class D, correct? Okay, so obviously we must get permission to fly within that airspace. The top of that airspace, notice it has the 70 with a little square, dash square. That's the top of the airspace. Wow, that's pretty high, right? No, not really, because the airport elevation is right down here, 4,452 feet. So it's not that high. It's just a high altitude airport. Anyway, so what would you monitor? Okay, again, you're trying to listen for manned aircraft. They'll be talking to the tower, getting permission from the tower. You're in that area, just outside that area. You want to know where the manned aircraft are flying, including helicopters that might be flying at 300 feet. You would listen to control tower. Since it's a control tower, you listen to control tower. That's this one right here, CT 119.1. But you'd notice that there's a little magenta, there's a little C. It's in blue though. That still means CTAF, Common Traffic Advisory Frequency. So the implication is, if you put 2 and 2 together, sometimes the tower is closed. And indeed it is. And when the tower is closed, you use the same frequency, 119.1. And then you hear pilots talking to each other. One guy says, well, I'm 10 miles to the south of the airport, landing on runway 36. Another guy says, I'm 5 miles west of the airport, landing on runway 4. And so the guy that's 10 miles out says, okay, I'm looking for you. I mean, he'll use terminology that you can understand, not my vernacular here. But, you know, they'll talk to each other to sequence each other. Well, now you're sort of in the loop. Now you know what's going on, and you can try to avoid that airspace, especially if it's a helicopter. If it's a manned aircraft, they're probably going to be high enough so you're not going to have to worry about it. Still, you need to be familiar with what's going on, and you need to be able to do this, communicate properly. Again, when they talk, they're going to reference Pocatello, either Pocatello Airport or Tower, rather Pocatello Tower, or if the tower is closed, Pocatello Air Traffic or Pocatello Traffic. This is Cessna 247, 10 miles south of the airport, landing on runway 36, Pocatello Traffic. Or if it's a tower, they'll say something like Pocatello Tower, Cessna 246, 10 miles south, request landing, Pocatello Tower. And then the tower will come back and say, well, Roger, get to report 5 miles, final, etc., etc. Okay, so that's the frequency we need to monitor, CT, since it has a C. But it may not have a C. In that case, the tower is open 24 hours a day. But again, this airport is, it's a Class D airport, so it's somewhat busy, but it's not a giant airport. Here's another uncontrolled airport, magenta. Again, if we're going to monitor air traffic, we're going to look for the little C there, and it says 122.9. Something about 122.9 that's of interest is that it is also what they call multicom, which means if there's no frequency at all, like a private airport or something like that, that's the frequency they're supposed to use, 122.9. If nothing is listed on the chart, then 122.9 is the frequency that you're supposed to use. They put it on this one for some reason, I don't know. Remember that within this circle, it's 699 feet, and to the surface is Class G, good to go. Outside this area, all this area out in here is 1,199 feet, and below is Class G. Or look at it the other way, it's above 1,200 feet, it's Class E, and inside here, above 700 feet and above is Class E. But the main point here is that we're looking for the CTAF, whatever that number is. Okay, here's another one, Blue Airport, Mountain Home. Okay, this does not have a little C, so Mountain Home Air Force Base, which would make sense. Control tower 33.85, 24 hours a day. If you want to get within that airspace, you need to call or get permission from the control tower there. And again, Class D airspace, dashed blue line. And we might as well look at Mountain Home right there. Mountain Home has got 122.8 with a C. That's Common Traffic Advisory there. Asheville. What kind of airspace? Solid magenta. Class C airspace. Notice the funny way it's shaped. shouldn't throw you off too much because there's mountains on either side because nobody's going to be flying in that area, right? So they don't need to protect that area. Airplanes only come from up from the south or down from the north. 6,200 feet is the top of the airspace, of the sea airspace, and the bottom of it is surface in that little oval shape. But the point here, though, is what's the frequency you need to listen to if you want to fly around some of those towers? Well, control tower 121.1 or the little blue C, when the tower is closed, same frequency. Northwest Alabama Regional Airport, dash magenta, class E, surface. Okay, the dash magenta line, surface up. It's an uncontrolled airport. You listen to, for traffic, you listen to 123.05. That's where the C is, right? E, surface, but then out here it's 700 feet E. Out here it's 1,200 feet E and above. So surface in the inner ring, 700 feet because of the shaded area, 1,200 feet outside the shaded area. In addition, if there's no radio communication, sometimes manned aircraft, their radio fails. If it is possible that if you're operating within controlled airspace, the tower, it may be part of your waiver, the tower may flash lights at you to give you those signals. So you won't need a radio. If you don't have a radio, they can flash these lights at you. Most for a drone pilot, they're probably not going to clear to land or take off or a lot of these things, but they could give you a red-green, which would be extreme caution, and this would be something you could prearrange with them to make these signals mean something else. Not a lot of data yet. There's nothing published yet about this, but you can imagine if you see a steady red, they're telling you go away, or get out of the way, or go lower, or something like that. Whereas if it's a green, either green or flashing green, that's like, yeah, you can operate, you're good. So there's just some possibilities anyway, but manned aircraft need to know this so they can operate if their radio fails. It could be useful, especially when you get around to doing a waiver.